not freeze at 0. Water freezes where? 32. What's going on there? Well, that scale was chosen for a different reason. 0 on the Fahrenheit scale is where a brine solution freezes. Does anybody know what a brine solution is? It's basically salt water. Okay? So this had to do with like stuff that was being done with chemistry in the lab. All right? So it was chosen so that the starting point was based on the freezing point of salt water, right? And then one of the other properties of this brine solution. And then the scale was chosen basically based on angle increments all the way up through. All right. So I basically get 0, 360, right? And those are my numbers, right, that I'm interested in. All right. And then scale through there, right? But 0 is different. Why is it different? Because it marks a property of a different thing in terms of what I'm trying to measure. And does it mean that that it can't get colder than the point where a brine solution would freeze? No, it doesn't mean that. It means that that's my starting point. That's what's of interest to me. Is that okay? And so I can still go above and below it. I want to have some way of denoting that and marking that. So how do I go below it? I just extend my line and keep making my little markings. And I have an indicator so that later on, if you wrote the number down, I wouldn't need the number line there to know where it was. Does that make sense? Right? Otherwise, I mean, I guess I technically wouldn't need to put a negative sign. Maybe I make all of those colored in red and all the top ones colored in black. Is that okay? We do this with money, right? Red means you owe it. Black means you got it, right? That's where Black Friday comes from, right? Does everybody know that? That's why we call Black Friday, is because that's when all of the companies expect to sell enough merchandise that their company will be in the black in terms of finances, right? If they were losing money somewhere, they hope that they're going to make enough money on Black Friday to put them in the positive, right? In the black region when they look at their books, right? So that's where Black Friday comes from, all right? So we could make them black numbers and red numbers, fine. But we don't. We make them positive numbers and negative numbers, or plus numbers and minus numbers. And we'll see when we do the arithmetic that that's a very reasonable thing from a mathematical standpoint to do. It's a reasonable thing to write. Is that okay? Going along with sort of the red and the black and the money, all right? That's another way to sort of tie into kids the idea. 0 is me not having any money. Is that okay? If I'm at 0, I don't have any money. If I'm at 4, I have $4, whatever it is, right? If I'm at -2, that means it's not just that I don't have any money, but I still owe you $2, right? There's a balance. There's a negative balance. Right? I know we've all experienced this, I'm sure, as adults at some point in time. I know I've experienced it. But this is something that's very practical to the kids, right? This is not just some abstract symbols and moving on the number line and extra symbols to put in front of the numbers, right? It's very concrete in terms of gain and loss and that kind of thing. And so I can talk about this idea of the integer in a very, very practical, reasonable way, right? For things from everyday life, right? It doesn't just have to be some abstract thought exercise. It can, but it doesn't have to be. And I would argue that it doesn't need to be at the beginning. It should be very practical and reasonable, right? How am I going to point out that Johnny owes me money? All right, we're going to create a new number. We're going to create the 5. Johnny owes me $5. I'm going to create a 5 and I'm going to put a minus by it, right? And that distinguishes it from Susie having $5. There's going to be a 5 with a plus by it. Is this okay? That's very practical and very reasonable. And kids play around with money at very early ages. I guess my youngest ones now are in 2nd grade. And I mean, they've been doing money since 1st grade. I guess kind of in kindergarten they were doing money, but definitely doing it in 1st grade. And so they're playing around with money all the time. It's really funny. Like anytime I have to go to the bank, like I'll say, hey, I'll be back. And my wife says, where are you going? I'm going to go to the bank. So the little ones, like as soon as I say I've got to go to the bank, wait. So they go to their room, they get all of their money. They get all of their money and they come to the car, right? And what do? They just want to exchange it. They don't care how. They're like, okay. So they're like counting out the coins and they're like, hand me a pile of coins. Okay, I want $3 bills for that because that's $3. And like, so we'll go and like, I'll do my transaction. I'm like, okay, now I've got the transaction for Ben. And like, I'll like drop this pile of coins. Ben wants 3 $1 bills, right? Jack wants two $2 bills and a $1 bill. He doesn't like his $5 bill anymore, right? And so they're just doing all this arithmetic and all of this exchange. And then eventually we play Monopoly. And then they learn what negative money is, right? And so like, this is natural stuff, right? For kids to learn and experience. And you can teach it to them in very natural ways, very practical ways that are hands-on and still engages them in the topic. So integers are very, very natural in our world, right? We use them to identify things all of the time, right? We could identify it as going to the left as opposed to going to the right, or north as opposed to south, or east as opposed to west, or you're going to go 4 blocks this way as opposed to 4 blocks that way, right? There are all ways that we can indicate sort of a distance and a direction, all right? The generalization of this idea of an integer into higher stuff later on would be something we would call a vector, right? Something that has what we call magnitude. It has a size to it, and it has a direction, right? And this is the first instance that we're going to have what we would call a vector type of idea. In our case, there are only 2 directions to go, this way or that way, all right? And then the magnitude is how far you go in that direction. Does this make sense? All right. Later on, right, you can throw, then you get out into a coordinate system and you go a direction for a certain distance, right? And so it extends and there's positive numbers and negative numbers all over the place because you got to be able to identify wherever you could go from whatever it is that you mark as 0. Does that make sense? And this is the beginning of that, but it's very physical. It's very practical, right? It's not just some abstract thought up thing, right? So this is the beginnings of the idea of vectors, that I have a magnitude and a direction, right? I can go this way, I can go that way. And again, we always talk about math being abstract, right? Math is abstract, math is abstract, math is abstract. I think the important thing when we work with kids is that since math is abstract, we should be able to use it for a whole lot of stuff. Does that make sense? The usefulness of it being abstract is that I can take this same idea, this sort of abstract idea, and I can use it here and over there and over there and over there, right? And so I should be able to give sort of a list of applications and interpretations that are concrete for positive things and negative things, okay? Gaining money and owing money, gaining money and losing money, temperatures warmer than the freezing point of water, colder than the freezing point of water, moving to the left, moving to the right, like all of these things. I can give a lot of very practical instances of why we need this extra identifier, right, that we're going to call the negative symbol for the number, okay? And the negative looks like the subtraction symbol for a very important reason, and we're going to see that as we go through the arithmetic, all right? So what are the things that we're going to see? Do you remember we used that word closure? Do you remember closure? Closure was if I pick 2 things out of the pot and I do an operation with them, I get another thing that was from the pot somewhere, all right? And so we said when we had whole numbers, addition gave us closure, right? And multiplication gave us closure. Subtraction did not give us closure. Do you remember that? We said subtraction won't work. Why does subtraction not work? Because if those were the 2 things that I pulled out of the pot and I subtracted them, I don't get something in the whole number pot. I get something else. Once we bring in integers, subtraction is closed with the integers. Now subtraction's fine. If I subtract integers, I still get an integer. I can't get anything else. Okay? So as we're going to see as we sort of extend our idea of numbers and what we can do to represent numbers, we're going to extend what operations can be done and not leave into some other world. Is that okay? So for whole numbers, addition and multiplication were just fine. Division was off limits, right? Division was not closed, and subtraction was not closed. If integers give me closure of subtraction, what's going to give me closure of division? Fractions. Is that okay? So again, it's this natural progression. How do we get these extra things? Well, I want to be able to do these operations all the time. That seems reasonable to me. But right now, with just the whole numbers, sometimes when I do these operations, it doesn't give me an answer. Does that make sense? So I need to extend my thought about numbers, right? Because it wasn't that there wasn't an answer. It was just that I had not cooked up enough to be able to write it down. Does that make sense? Like my view was limited, so I have to expand my view. The first way that we're going to expand our view is to move in the other direction and get the integers. The next way that we're going to expand our view is actually by zooming in and saying, there's got to be a way for us to get stuff in between these two marks. Is that okay? And then as we get on into decimals, we'll see that we're going to be able to fill in the final gaps in this line and cover everything. All right? So we're going to see that we're as we sort of build our numbers, we can always do it. All right? How are we doing? Cool beans? All right, so there's our introduction to integers. All right? Next time, we will I think we all kind of know the representations of integers, so we'll talk about that briefly, and then we'll get into the arithmetic and how it works and how I can illustrate it and what we can do with it. All right? So have a great day. I know we're done a little bit early, but have a great day today.
Thank you.
You're welcome.
And I know someone wanted to know in the chat, they said, so only chapter 3 and 4, except for 3.2 and 3.5, since they were on the last exam, will be on the next test, right?
Right. Yeah. The stuff that was on the last exam will stay there. So just the new stuff we did in chapter 3 and the chapter 4.
Okay, perfect. Thank you.
All right. You're welcome.